Hi, so today we are going to talk about heat and thermodynamics. Okay, so we'll start the discussion today. You know that I'll give you an introduction first, and then we'll move on to the next further topics. So first thing, what is heat? Or in NCERT it is given that given as two chapters. One is thermal properties of matter and then thermodynamics. So actually both the terms like heat and thermodynamics, that is also an appropriate name, because we are going to talk about what is heat, then temperature, and heat is actually energy, right? So the energy, the flow of energy, and all those things we will discuss. And after that we will move to the thermodynamics. That is the real, like the energy conversion and everything. Okay. So anyways, heat. First of all, you have to have in the introduction. I would like to talk what is the difference between heat and temperature. Heat and temperature. So what is heat and what is temperature? So that is the first thing we should definitely have an idea about. So you know that heat is nothing but it's an energy, right? It's energy. I'll give you a simple example, and then from that example you will get the idea. So you have a cup of water. Okay, in a cooking pot, you have taken some amount of water, and the water is, you filled the water and you kept it on you kept it on an induction cooker. Okay, for the sake of understanding, I would like to take a electric induction cooker. Alright. So now induction stove, you must have seen, right? Alright. So the thing is, if you increase the heat, if you switch on it and if you increase the heat, then it will get heated. So what is exactly we are doing? The process is, this is my cooking pot. Suppose this is my induction stove. Then the water will get heated. Everyone knows that. So you know that, okay, my induction, this is connected to a plug point. Okay, fine. So look at this. Here the induction cooker is actually giving heat energy to what? To the water. So the water will get heated. And one thing it is very sure. So initially the water had less heat energy, and finally the water will get more heat energy. So heat is nothing but it's an energy. So we can just like other energy, the heat energy will transform to other forms of energy as well. Alright, so that's it. So it is heat. So what is temperature? What is temperature? It is nothing but it is the measure of heat. It is the measure of heat energy. What is the meaning of that? One simple example. I would like to give you a simple example. Again, this got heated. Okay, so this water is like now it's almost like a boiling point at that stage. Anyways, more than room temperature. Alright. So suppose someone came, for example, your little sister, little brother came, and he asked or she asked that, okay, brother or sister, like what is what is how much heat energy it has? Okay, that is a question. Okay, so you said it got heated. How much heat it has? Okay, because kids ask a lot of questions, right? Okay, so what would you say? Or they ask, what is is it heated or not? If it is an yes or no question, then you can easily answer the question. How? You can just touch it, or you can feel it, and you can do not touch it like if it is 100 degrees Celsius or not. But usually you can touch it and you can feel it. Okay, then you can say that, brother, like, or sister, okay, this is it got heated. The water is like very hot right now. You can say that. But how much heat energy you have? How much heat energy the water has? Okay, how would you say that? How would you tell your brother or sister that is what is the amount? So that is why we have temperature. We need to measure it. We need to. I always tell students that like physics is always about the measurement. Whichever quantity we are discussing, we have to measure. So here also the temperature is the measure of heat. For example, if you have a thermometer and you can put it in and you can say that, yes, it is 85 degrees Celsius. So we'll get an idea. What is the room temperature? What is the 85 degrees Celsius? What is 100 degrees Celsius? What is 0 degrees Celsius? We have an idea about it. So that is what is temperature. And one more thing in the introduction I would like to talk about. What are the units of heat and temperature? Heat, what is the unit of heat? The unit of heat is joule only. Joule. Or we can have calorie. Okay. We can have calorie or joule. That is it. Because heat is nothing but energy. We can use every units of energy. Right? So what about temperature? What about temperature? What is the unit of temperature? The unit of temperature is nothing but it is Kelvin. This is the SI unit, Kelvin, and there are other units as well. You know that in our day-to-day life we don't use Kelvin. So I would like to let you know that Kelvin is mainly for our physics problems. I always tell like the Kelvin is for physics problems. Degree Celsius is for our day-to-day life. For example, our weather, our like how much degree Celsius is there, like that. Like. Okay. So another one is degree Fahrenheit. Degree Fahrenheit. Degree Fahrenheit is for medical purposes mainly. So other units are also there, ranking, humor and all, but the conversion and all is not there in the syllabus, so we don't need that. Okay. So this is what is these are the units of what temperature and heat. And one relation we just have to keep Kelvin and degree Celsius. So you know that 1 degree Celsius or 1 Kelvin degree Celsius is equal to, how much is that? Degree Celsius? Kelvin minus 273.15. That is the value. Or when you want to convert degree Celsius to Kelvin, that is degree Celsius plus, how much is it? 10 degrees Celsius. 10 plus 273.15. Okay. So more things about this we will discuss later. Actually, in syllabus it is not there, but for the sake of understanding the problems, I just want you to know this one. Alright. So I think this is the introduction and we will move to the next topic, that is anomalous behavior of water. What is the anomaly water's expansion? Alright. So thermal expansion, the topic is not there for the exam. So that is why I am skipping that topic and we'll move to the anomalous behavior of water, which is interesting. See you.